In Activity 3, Friction, students examine friction and how it affects the amount of force needed to move an object a certain distance. Students first observe the effects of friction, then examine variables that increase and decrease friction, and finally discover one method of reducing friction. You will need the following materials from the kit: Activity Sheet 3, half brick, spring scales, pieces of string from Activity 1, wooden boards, petroleum jelly, sandpaper, masking tape, and wax paper. You will also need to provide meter sticks, paper towels, and a pair of scissors. To prepare for the activity, make a copy of Activity Sheet 3 for each student. Cut each sheet of sandpaper into strips approximately 8 centimeters wide and 25 centimeters long, and cut each sheet of wax paper in half. Each team of 4 students will need a brick, a spring scale, a meter stick, a 1 meter piece of string, 3 strips of sandpaper, 2 pieces of wax paper, a wooden board, a few long strips of masking tape, a dab of petroleum jelly, and some paper towels. To begin the activity, instruct students to stand behind their desks with their chairs pulled out. Tell them to push their chairs in, then pull the chairs back out again. Ask students, why did you have to use force to move your chair? Answers will probably involve the weight of the chair. Have students observe, feel, and describe the texture of both the floor and the feet of their chairs. Draw their attention to signs of wear. Ask students, what caused the wear? Students will probably say that dragging the chairs across the floor caused the wear. Explain that no matter how smooth a surface may feel, there are always rough spots, tiny bumps and craters on that surface. When the chair is pushed and pulled, the roughness on the surface of the floor rubs against the roughness on the surface of the chair feet, making it somewhat difficult for the two objects to slide past each other. Further explain that friction is the resistance created by two surfaces rubbing together. Next, have the students rub their hands together briskly until their palms become warm. Ask students, where did the heat come from? Guide the class to understand that when two objects are rubbed together, friction between the two surfaces produces heat. Distribute Activity Sheet 3 and the materials, and instruct the students to measure the length of the wooden board with the meter stick. Students should note that the length of the board is 0.6 meters or 60 centimeters long. Next, instruct the students to place the board flat on the floor or desktop and to tie one end of the string around the brick and the other end to the spring scale. Tell students to place the brick at one end of the board. Make sure that no string is under the brick as it is pulled. Then have one student hold the board still while another uses the spring scale to pull the brick the entire length of the board. Instruct students to record the force required to move the brick and the distance the brick moved on their activity sheets. Then have them calculate the amount of work done. Instruct students to place their sandpaper strips end to end and tape them to the board. Again, use the spring scale to pull the brick across the sandpaper the entire length of the board. Remind them to record their results on Activity Sheet 3. Finally, remove the sandpaper. Place the pieces of wax paper end to end and tape them to the board. Then repeat the procedure, dragging the brick the length of the board. Again, instruct students to record their results. After everyone is finished, ask students, in which of the 3 setups did you do the most work? Students should respond that the distance was the same for each trial and that they did the most work when they used the most force, when they moved the brick across the sandpaper. Then ask, why was more force needed to move the brick across the sandpaper than across the other surfaces? Students should recall that the surface of the brick seemed to get caught on the surface of the sandpaper, whereas the brick slid easily across the wax paper. Point out that the surface of the wax paper is smoother than both the surface of the plain board and the surface of the sandpaper, and so the rough surface of the brick did not catch as much. Finally, ask students, in which situation did the brick and the surface of the board display the most friction? Which situation displayed the least friction? Confirm that the most friction occurred with the sandpaper and the least friction occurred with the wax paper. Next, ask students, what rule can you state about friction and the surfaces of objects rubbing against one another? students should realize that the smoother the surfaces that rub together, the less friction there will be. Ask students to consider other variables that might increase or decrease friction between two surfaces. If the students do not mention it, prompt them to think about wet and dry surfaces. Tell students to rub their thumb and forefinger together and listen to the sound it makes. Explain that the sound is produced by the friction between the surfaces of their fingers. Walk around the room and apply a dab of petroleum jelly to each student's forefinger. Ask them to rub their thumb and forefinger together again. Ask students, what do you observe now? The students should observe that the sound has been reduced or eliminated. Explain to the class that a lubricant is a substance that reduces friction between two moving parts. Petroleum jelly, oil, grease, and other slippery liquids are examples of lubricants. Make sure to distribute paper towels for the students to wipe the petroleum jelly from their fingers. To conclude the activity, have the students discard the wax paper and the paper towels and return the wooden boards and spring scales to the kit. They should leave the strings tied to the bricks for use in Activity 4. Save the sandpaper strips for use in Activity 5. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.